Picture a bell at the top of a faraway bell tower. Now, just by looking at the bell, you can learn certain things about it already, like its shape or its color. And that might tell you certain things, like what it's made of. And heck, if you were clever and you even knew how far away the bell was, you might even be able to figure out its size. And all that's cool, it really is. But now, suppose you could listen to the bell ring. Now, that would tell you something different because, well, a hollow bell sounds different than a solid bell, sounds different than a bell filled with cheese or whatever. And so suddenly, by listening to the rings of the bell, you learn information not just about the bell's surface, but also its deep interior, which was something which was before just totally invisible. The idea of astroseismology is pretty much exactly like that, but instead of listening to bells, we're listening to stars. One of my favorite kinds of stars to listen to is the red giant, a puffy dying star with a dense helium core at its center. Red giants have unending starquakes owing to constant stirring and ringing by convection in their outer layers. And by monitoring the changes in brightnesses of these stars, we can listen in on those starquakes, peer underneath the surfaces of these stars, and measure the masses of those helium cores. I'm going to oversimplify a little bit, but essentially more massive stars will make and have more massive cores. Now that kind of makes sense. And so indeed, when we go and look at them, red giants tend to have the cores with about the masses that we expect. But every once in a while, you stumble upon a red giant whose core is just a little bit too light. It'd be like wandering into a bell factory and finding a single solid bell in a pile of hollow ones. Now, you might not know why this bell is different, but you know that it is, and that it was probably made differently somehow. And in the case of stars, well, an undermassive core rather suggests that the star was less massive when it made that core than it is now today. That means it had to pick up that mass somehow. And so we've discovered, using astroseismology by listening, a way to tell, even potentially millions of years after the fact, that a star participated in a violent stellar merger event. That is only one of the many problems about which astroseismology has something to say. You know, we astronomers, we care so much about looking. We build these gigantic telescopes for billions and billions of dollars. We even shoot them into space just so we can look at stuff harder. But astroseismology teaches us that there is a heck of a lot more we can learn about the stars by listening. Thank you.